Alright, so hello and welcome back to OneClass. Again, my name is Joey. I'm going to be your math teacher for this session. So again, I streamed earlier at 10 a.m. We looked at problems in terms of grade 9 algebra and grade 9 geometry. And what we're going to do now is we're going to look at some higher level math. So again, grade 11, grade 12 mathematics in the Ontario curriculum. And particularly if you're tuning in from the US, it's more so in the pre-calculus slash algebra 2 kind of problems here. So we're going to focus on those problems today. Again, if you're tuning in for the first time, thank you so much for watching. What we're doing here at OneClass is that we're providing online lessons, and in those lessons, what we're doing is we are answering questions compiled by OneClass and asked by you folks at home. So we compiled a bunch of math and chemistry questions in the secondary school and in the university and college level as well. And what we're doing now is we're answering those questions together, and I'm going to explain to you my thinking as we go through these solutions, so that hopefully that we might better prepare you for a test, or you might learn the concept in a different way. So without further ado, let's get started on. We're going to do 10 problems for today, and it's probably going to cover grade 11 math and grade 12 math as well. So let's get started for today. Okay, so first question comes in. It's asking, how do you convert 90 degrees to radians? So it says here, right here, this is how do you convert, or I'll just say convert 90 degrees to radians. I'm not going to write out the full question. Convert 90 degrees to radians. So take a moment to think about this. It's a trigonometric problem here. And what we're doing is we're working with units in degrees, and suddenly we're now working units in radians, right? In grade 11 math or in algebra 2, you were introduced to this unit of radians. So how do we convert from degrees to radians? So remember, just a hint here, I have pi here. Pi in radians equals 180 degrees here, right? And 2 pi, which means 2 pi is 360 degrees. So if I were to convert 90 degrees into radians, what I would have to do is if I have, again, if I have 90 degrees, is like what's kind of what number belongs here? Like I do know it as x, right? What is x here, right? And if I want to solve for this, I can simply just say, if I know x equals 180 degrees, so if pi equals 180 degrees this equals 9 degrees, then I can simply divide out 180 by both sides, right? Which means x equals 90 over 180 degrees, which also equals half, right? It's half pi would equal my radians here in this case. So let's see, just erase this for you, and this is simply just half. This is I would get pi here. So x would equal half pi, or half pi. So this here, if I convert 90 degrees to radians, therefore I can say that 90 degrees equals half pi in radians. So like you see, it's multiplied by a fraction. So the solution says multiply by a fraction represents 1 revolution. So to convert from degrees to radians, they said 2 pi radians equals 360 degrees. That's what we did here, which means that here it says the conversions, because I'm going to skip this. This is more so background stuff. And it's saying pi radians equals 180 degrees. So basically what you're doing is 1 pi radians equals 100 divided by pi degrees. So you multiply that to convert to degrees. So what they did here was radians, or I can say rad here, equals 180 divided by pi degrees, or pi degrees here. And basically, if I know, and this here can be times anything, right? This here is my degrees here. So basically it's saying rad here equals 180 divided by 90 pi, right? 90 pi, which was also give us half pi here. So exactly the same thing as what we're doing. It still gives us half pi. Therefore, I don't think they answered the question here. That's so weird. I don't know where pi over 2 is. Oh, this here is pi over 2, maybe. I think that they should have written a slash here. So let me just Let me just verify this here. So great solution. I think you meant pi over 2 equals 90 degrees instead of just pi 2. Is that what they wrote? They wrote pi 2, right? Yeah, pi 2 radians. So obviously solution is correct, and this here is the correct answer. So that's number 1. It's half pi. This here is my answer here. Half pi is my answer for question 1. Sweet. Let's look at question 2. So question 2 states that what is the quotient of x cubed minus 3x squared plus 5x minus 3? So there's a lot of ways to actually solve this problem. So let me just write this down first. So it says here, what is the quotient if I, so x cubed minus 3x squared plus 5x minus 3, and I'm dividing it by x minus 1. So again, what I'm doing here, this is the concept of, you would probably learn this concept in polynomials and polynomial functions, specifically in grade 12 advanced functions. If we were to find the quotient or something, the quotient of 2 polynomials, what we would do is we would use long division, right? So again, you choose to use long division, or you can use synthetic division. I'm going to choose to do long division in this case. So I'm going to put this here. I have x cubed minus 3x squared plus 5x minus 3, and I have x minus 1 here. So what I'm going to do is, again, I'm taking x minus 1, I'm multiplying by something to get x cubed. In this case, I'm multiplying by x squared, which means x squared times x, I get x cubed. X squared times negative 1 is minus x squared. And this here I'm subtracting. This here is negative 3 minus x, right? So minus 1 would give me negative 2x, right? Negative 2x squared. I bring down the plus 5x here. And then I'm doing now the operation x times what equals negative 2x squared. I'm going to need negative 2x to fulfill this condition. So negative 2x times x is negative 2x squared. And then negative 2x times negative 1 here is positive 2x, right? Subtract those things together. Negative 2x squared minus 2x would simply be 0. So that cancels out. And 5 minus 2 is 3x, right? So 3x, I bring down the negative 3 here. Just make some more real estate here. And 3x minus 3, I'm multiplying what number to get 3x? I would multiply by positive 3. Positive 3 would give me 3 times x here is positive 3x. 3 times negative 3 here is minus 3. Subtracting these two numbers, and I get a remainder of 0. So 3 here, this here is 0. So 3 minus 3 is 0. Negative 3 minus 3 is also 0. So here, the quotient for this problem, the answer to this problem is this here, right? Oh, sorry. Let's make a box here. It's x squared minus 2x plus 3. So you can rewrite this solution as, you can now say that this here equals x squared minus 2x plus 3. And if you actually, what you could do to verify this answer is you could use distributive property and multiply these two together to get our solution, our question here, if you want to verify with that. But here is my answer, x squared minus 2x plus 3. Let's verify the solution. We use long division, so it's good. They don't show you the long division here, but I'm pretty sure, so it says here first, I'm pretty sure they're fine with it. So as the first, we need to divide the first term, which gives x squared, that's good. So you get x cubed minus 2x, good. You subtract that from this, you give it negative 2x plus 5, that's good. Minus 3 is the remainder, but we solve further. Then you get negative 2x, good. This will be the second term. Then we multiply the divisor by negative 2x. You get negative 2x plus 2x, that's right here. You subtract those two, you would get 3x minus 3, awesome. Now we follow the process again, and you get a 3, which is shown here above. You get 3x minus 3. You gives us 0, which means our answer is x squared minus 2x plus 3. Great solution and step-by-step analysis. So this here is a correct solution and analysis here. I wish that they kind of like drew it out, like attached like an image file, instead of verbally, instead of writing it out in words, but this was a clear explanation. because I could follow it and I could follow these terms in terms of what these steps are here. So this here is a great solution, like an image. Oh, this is it. This is an image file. So this here solution is correct. This is that was question 2. Let's do question 3. So here, which of the following is a stretch exponential decay function? So it says here stretch exponential decay function. So we'll stretch exponential decay function. Let's look at number 1 here. So A here states that this is 4/5 times 4/5 to the power of x. Is this a exponential decay, stretch decay function? Stretch exponential decay function. So what we have to do first, we have to think about what is an exponential, what is a decay, what is a stretch, right? So let's think about these questions first. Actually, let me erase A. Let's think about just this problem here before we even go to the answers here. So the term stretch means that my graph here is horizontally or vertically stretching, right? When we talk about a vertical stretch in particular, if I look at my answers here, I'm only affecting my this is affecting the A value. So it's talking about a vertical stretch. When we talk about a vertical stretch means that it has to be greater than 1, right? A has to be greater than 1 for me to fulfill this here. So if I look at my graphs here, A is greater than 1, which means A here is wrong and C here is A and B are wrong here, right? Because these 4/5 is not greater than 1, it's 0.8, which means these two are the incorrect answer for these ones. So we're looking at C and D now. C and D has a value which is of A equals greater than 1, but it doesn't have an exponential decay. So when we talk about exponential decay, we're talking about the base has to be between 0 and 1, right? My base of my function has to be between, and I'll say the base would be, let's say B. B has to be between 0 and 1, right, to get an exponential decay, right? If you recall, an exponential increase function would something be like y equals 2 to the power x, right? But for a decay function here, it looks like something like this. And this here would be like y equals half of x, or half to the power of x, or something like that. This here is an exponential decay. This is what we're looking for. This is a decay function, and this is an increasing exponential function. So we're looking at that. If B has to be between 0 and 1, which means between C and D, only D is my correct answer, right? A is greater than 1, 5/4 is greater than 1, and 4/5 is between 0 and 1. So in this case, D here is my correct answer for a stretched exponential decay function. So let's look at our answer here. It says y equals AB, where A is a scaling factor, which is the vertical stretch factor. That's good. B is the base greater than 0, and x is the exponent where it's x an exponential function, right? So they're saying that y equals a b to the power of x, which is good. If A is greater than 1, then exponential function will stretch. If A is less than 1, then it'll be compressed. If actually A is less than 1, it has to be, it's actually, so this here is actually, the condition here is wrong, right? When we say the exponential function is compressed, we're just saying that it's between, A has to be between 0 and 1 for it to be compressed, not just less than 1. So this is a compression. Because if I had a negative value in this case, it would actually reflect along the x-axis and also be stretched, right? So you can you should add the absolute value bar here, or just say if it's between 0 and 1. If B is greater than 1 and it's exponential, good. Called growth, that's good. That's another word for increasing function. If it's between 0 and 1, it's the decay function, that's good. To find a stretch and decay function, we need A is greater than 1 and B has to be between 0 and 1, hence D is the correct answer. Good. This is a great solution. Great solution. And analysis. I'm just going to correct their if statement here. The statement here is incorrect. It's incorrect because A has to be between 0 and 1, because if compression, or so this is a vertical compression. Vertical compression exists when it's between 0 and 1 here, not A is less than 1, because there exists a, because if it's a negative integer, then you get a reflection, right? So that's the only reason why I'm saying this here. Great solution analysis, however, so I'm just saying the solution is correct because their solution here is correct. They just have a different their logic there was slightly flawed there, but with this exception, but it's totally fine. This here is the correct answer for number 3. Let's look at number 4. Asking a future value problem. So this is a grade 11 financial math. It's actually only specific to grade 11 math, and it's specific to the Ontario curriculum. So it's actually, I don't know if you learn this in the US curriculum. It might be in another course, like a financial math course. But in grade 11 Ontario curriculum, we have a unit with financial math and applications, and this is where this plays out here. So it's asking us, what is the future value? So what is the future value of, this is $800, 1 year from today, if interest rate, I misspelled interest rate is 7%. So what is the future value of $800 1 year from today if interest is 7%? So basically, if you were a grade 11 student approaching this problem, you would actually get an equation or an equation sheet, right? Where basically you know that basically all your equations. You know, compound interest, simple interest. You know, future value, present value, future annuities, and present annuities. So you know you have all these equations that you're given. I don't think you're expected to memorize these ones, just because it is kind of tedious in terms of memorize these equations. But what if through a formula sheet, what you would have gotten is that you would have gotten that this formula is FV for future value equals, it's the present value, so PV, or you can say principal amount, times is 1 plus R over M, where R here is the annual interest rate. M here is the number of periods based on compounding frequency. So it depends on how if it's compounded value here. So in this case, I think it's just 1 year, right? If the interest rate is 7%, because if it's bi-monthly or if it's weekly or something, that we would have to change this M value. And then we have M here again times T. T here would just be the time, right? So in this case, it's 1 year. So let's solve for this problem. FV, here's future value. So we're solving for future value. Our present value is 800, right? $800 is what we have now, right? We have $800 now. And we have 1 plus the rate, in this case, is 7%, right? 7%, we have to convert that to a decimal. So 7% is 0.007, right? 0.07 divided by M, which is the number of periods based on compounding frequency, right? So in this case, I'm assuming it's an annual interest rate of 7%. So there's only one compounding period. So in this case, it's only divided by 1 times M, which is also 1, times time, which is also 1, right? There's also, it's only from 1 year from today, right? So in this case, I can simplify this as 800. 1 plus 0.7 divided by 1 is simply just 0.7. And 1 times 1 here is 1, which is just to the power of 1 here. So basically, all I'm doing is just 800 times whatever 1.07 here. 800 times 1 plus 0.7, which is 800 times 1.07, which would equal my value in the future value would then equal $856 for this problem. So my future value is $856. So let's look at the problem here. So it's saying given principal amount is 800. That's good. Rate of interest is 7%. Time period is 1 year. We use this equation here, P 1 plus R to the power of T. I don't like how they did not include the M here. Like, it is implied that it's the compounding period is 1, but if, for example, if it was 7% like biannually or monthly example, then this equation changes. So I actually don't like the equation that they're using here, but it still gave us our correct answer of 856, and they subbed in everything correctly, I believe. They just divided by 100. Let me see. P is the principal amount invested, R is the rate of interest, and T is a time period in years. And they did 1 plus 7% here, which is 0.07. So this here still gave us a correct answer. So I'm going to say good solution. However, I'm going to copy and paste this formula. However, this formula, the formula does not account for number of compounding periods if interest rate was monthly or bi-weekly, for example. A better formula to use would have been, and my formula is FV equals PV times 1 plus R over M to the power of MT, right? Where M it equals basically the number of compounding periods, the number of compounding periods. Sweet, so solution here is correct. I just didn't like their formula that they used, but it's okay. Solution here is correct. And we're off to question 5. Okay. Yeah, this is question 5. Using complete sentences, explain the key features of the graph of the sine function. Okay, so this is a grade 11 problem where it's approaching sinusoidal functions for the first time. It says explain key features of sine function. Okay, so we're given this sine function here. They actually use Desmos, which is nice. And what we're doing is we're explaining the key features, right? So we can say key features of sine functions. We can use the complete sentences. I'm just gonna verbally say my key sentences, so it's not tedious for me to write. But I can say a sine function is continuous, right? It has it extends in terms of x. Its domain is x is all real numbers, right? So for a sine function, if f of x equals sine x, domain, for example, the domain of this function is xer, right? Xer. It exists in all radians, right? Obviously it repeats and repeats, but xer for those periods as well. And then my range, for example, as you can look at the y-axis here, it goes up to 1 and then goes down to -1 here. So so for y has to be between -1 and between -1 and 1 here. So y has to be that, and y is obviously all real numbers as well. So that's my domain and range for this function here. I have an x and y intercept of 0 and 0, so I can say my x-intercept, y-intercept is 0 and 0. Or my y-intercept is actually just 0, right? Because I have multiple x-intercepts. So let me rewrite this. So y-intercept is 0, 0. X-intercepts I actually have, it consistently changes to there's an interval, right? So like if you look at the graph here, at 0, 0 crosses the x-axis, at pi it crosses the x-axis, at 2 pi and so on and so forth. So it actually crosses at x-intercept is at n pi. So if x is at n pi, so here it's every n pi. So where n equals basically any integer, in this case any integer. So it's like 1, 2, or plus or minus 1, 2, 3 and onwards. So basically that's kind of my condition for my x-intercept here. And as you can see, there's you can see other functions here. There's an amplitude of 1. Amplitude of 1 meaning it goes towards 1, and its max is 1 and its minimum is 1. So I can say maximum is 1, minimum is -1. And I can also say its frequency, right? Its frequency, or sorry, in terms of period, right? Period. So for one cycle of the function is every 2 pi, right? So it goes up, as you can see, it goes from 0, 0, from 0, 0, it goes to pi over 2, goes to pi, goes to 3 pi over 2, and then it goes back to 2 pi, and then it keeps repeating this pattern, right? So every 2 pi is one cycle, or one full cycle of this sine function here. So I hope that's enough information for kind of the sine function here. I have domain, range, y-intercept, x-intercepts, maximums, minimums, and periods. And I think that's about it in terms of this function here. So let's say, as we can see, the graph goes up 1 unit, down unit from the middle line. So the amplitude of the graph is 1. That's good. Since sine is a periodic function, it repeats its value or cycle after a value of 2 pi. Hence, the period of the graph is 2 pi. From the graph, we can see the maximum value is 1, minimum is -1. And the interval of 0 to 2 pi, the graph of sine has 3 intercepts. So this here is good. I would have liked to include a domain range, and also how my x-intercept repeats every n pi here. But that's about it. I can't really ask for more here. So maybe I'll say this is a good solution. Actually, you can also include domain and range of the sine function, and also specify that x-intercepts exist for every n pi, where n equals, and this is plus or minus 1, 2, 3, and so on. Basically every integer for that, because again, it repeats both for the positive and the negative signs here. So this here is correct. This solution here is correct, but you can also include a little bit more information when we talk about this graph here. So the solution is correct. Okay, let's look at question 6 here. So which statement is true regarding the graph function x? So let's look at 6. So basically, find true statement. Okay. And it's saying I have a is an increasing degree, or sorry, f of the function f is an increasing function. It's a decreasing function. F of x tends to infinity as x tends to positive infinity, and f of x tends to negative infinity as x tends to negative infinity. So let me write this out. So a here is increasing function. B here is a decreasing function. C here is a f of x tends to, so as basically it's saying as x heads to positive infinity, f of x also heads to positive infinity. So I'll say as x approaches positive infinity, f of x approaches positive infinity. And D here says that if as x tends to negative infinity, f of x tends to negative infinity here. Okay, so it's asking which statement is true for the graph function below. Okay, so find a true statement. Let's look at 1. 6a here, is it an increasing function? It is an increasing function, but it's from here to here, right? So it depends on what you can specify this as an increasing function only at this point. It's only from like this here would be, I don't know what the x-intercepts are, or I don't know what the vertex here is. I can maybe approximate here. That's -2. I guess this is 1. This is from like half, and I'm assuming this is 2.5. So from where x is equal to 2.5 and onwards, so from x equals 2.5 and onwards, it is a increasing function, and from x equals 2.5 and backwards, it's also actually an increasing function actually in this case. Or no, in this case it would be a decreasing function because this value decreases here. So this here is a decreasing function. But however, the entire function is both increasing and decreasing. So in this case, A and B are both wrong, right? Because it's both in this case. So in this case, increasing and decreasing are both wrong, right? Let's look at C here. C here is as x approaches infinity, f of x approaches positive infinity. This here is correct, right? Because as x approaches like 4, 6, 8, 10, my graph is going up. Y is going to positive infinity. This here is correct. And if x is heading to negative infinity, f of x is negative infinity. This here is incorrect here, right? F of x should be approaching positive infinity. It's going up here and not down here, right? So this here is also wrong which means C here is my correct answer. However, I don't really like this question because when you ask what's an increasing and a decreasing function, this here is an increasing function. It's an increasing function from this period. Basically, the vertex is here. Let me just redraw this, and I'll show you what I mean by how I don't like this problem, or I don't like the questions that they give with this problem here. I'm going to show you the blue one here. So if you have the vertex is like here, for example, this side here is increasing. And then this side here is decreasing. So like the function is both, it's both increasing and decreasing up until this, this vertex here. So in this case, like these two questions would have been, it's still the true statement, but this is more true. If that makes any sense at all. That's how you would answer these types of questions here. So C is correct. A is false. A function has to be increasing if g of x of 1 is greater than g of x2 whenever x of 1 is x at 2. So from the graph, observe, so they put f of 2 is here equals f of 3. F of 3 would be here equals 0. That means 3 is greater than 2, but f of 3 is not greater. 3 is greater than 2, but f of 3 is at 0. F of 2 is here, f of 3 is. F of 2 and f of 3 are both of these guys here are 0, but 3 is greater than 2, so it's not an increasing function. The function g is set to be increasing whenever this condition meets, and they're doing the exact same because 2 is less than 3, so it's not greater. Okay, so C is true, D is false. So I don't really like their explanation for this here, because in this case, you have a vertex here. It's a parabola, clearly. And what they're doing is this function decreases up until this point, and this function increases up after this point, right? So, like, technically, it's not false, but there should be a condition. It should be an interval. It should be like negative infinity. If I were to draw out the intervals of increase, I can say this is from 2.5 towards positive infinity, and then decreasing would be negative infinity to 2.5, right? There's an interval of increase and decrease. So I'm going to say great solution. However, explanation for increasing and decreasing functions can also be supported by stating the intervals of increase and decrease. So you can say that increasing function, and so square brackets, so this is 2.5 to infinity, and then decreasing function from negative infinity to 2.5. So this here would support the argument here. So solution is still correct. Great. That's number 6. Number 7 is the exact same. Weird. Number 7 is the exact same solution here. Yeah, number 7 is the exact same solution. Weird. Okay, so I think I picked this on purpose just so I can fill out both of them. I don't remember. Just give me a second. I think I finished. I did both of these guys here. Yeah. Yeah, I picked both of these because I wanted to finish both of them and just verify. Great solution, but can also include intervals of increase and decrease. And then you can say, I said that increasing here is from 2.5 to infinity. And then from decreasing is negative infinity to 2.5. There we go. So solution here is correct. So this, I guess that was 7. So I guess I think I picked I'm hoping I picked 11 questions. I think I picked 11 questions today. So 7 was the exact same thing, exact same as 6. So now we're doing question 8 here. So it says here, according to the fundamental theorem of algebra, which polynomial function has exactly 8 roots? So let's look at our function. Let's look at number 1 here. So it's asking polynomial. It's asking the question's asking how many, which function has 8 roots, right? So polynomial has 8 roots. So let's look at A here. A here states that f of x equals, this is 3x squared minus 4x minus 5 times, I need some more space here, times 2x to the power of 6 minus 5, okay. And then B here states that f of x equals 3x to the power of 4 plus 2x to the power of 4. C states that f of x equals, I have 4x squared minus 7 to the power of 3. And finally, I have D here is f of x equals 6x to the power of 8 minus 4x to the power of 5 minus 1 times 3x squared minus 4. So I have four functions here. So let's look at the first function here. I have 3x squared times 3x squared minus 4x minus 5 times 2x to the power of 6 minus 5. So let me just expand this in terms of, I could FOIL this, and I could expand this in terms of one long polynomial here. And if I were to expand this kind of function here, I would get 3x squared, or 3x squared, if I just do the first part of FOIL, it's 3x squared times 2x to the power of 6, right? So in this case, I would get 6x to the power of 8 is my first term if I multiply these two terms together. And I could do this with this one times this one times this one, and so on and so forth, right? But as you can see, my tall polynomial has a degree of 8, right? It's going to be my highest degree in this function here. So this here has 8 here, which is good because I want 8 roots, right? The second one, I have 3x to the power of 4 to the power of 4, right? So whenever I'm taking an exponent and I'm taking another exponent, I'm multiplying exponents. So my first term here would be whatever 3 to the power of 4 is, which is, let me use my calculator, 3 to the power of 4 would be 81, right? So this is 81 times x, and 4 times 4 here is 16, to the power of 16, right? So this here, obviously, it does not have 8 roots in my degrees. So the 16, it could have up to 16 roots. I don't really know how many, right? So that's not incorrect here. So B here is incorrect answer. C here, I have 4x squared minus 7 to the power of 3. I can take 4 cubed, and I would get 64. X squared times to the power of 3. Here's 2 times 3. Here is 6, right? Which is great. And this here just simply minus whatever 7 cubed is, right? 7 cubed is 343. 343, yeah. Okay, so that's good. That's okay. That my polynomial here in this case is 2 to the power of 2 to the power of 3 is 8. Actually, sorry, I don't know why I wrote 6 here. Oh no, this is 2 times 3. Sorry, 2 times 3 here is 6. So see here again, it's incorrect answer because it's actually the power of 6, so the degree here is 6, so it's not 8, right? So this here is also incorrect. And then finally, D 6x to the power of 8 times 3x squared here, I would get 18x to the power of 10, right? I'm adding these exponents. So in this case, you can have 10 roots, which is incorrect, which means A here has to be my logical answer because the highest degree here is 8. So let's look at the polynomial function. According to the fundamental theorem of algebra, a polynomial of degree n will have exactly n number of roots. It doesn't have to have exactly n number of roots. It's saying up to the n amount of roots, right? For example, a parabola could have 1 x-intercept, right? Or it could have 0 x-intercepts, or only imaginary roots, right? So it's not technically only 2, right? It's not technically up to the number, so it's fine. So we expanded this, so you got 6 to the power of 8, which is what I had here, so exactly 8 roots, that's good. Second polynomial has 16, like we wrote before. This here is 81x to the power of 16. Third polynomial has 6, which is 64x to the power of 6. And finally, fourth polynomial is 18x to the power of 10, which is the power of 10 here. Hence, option A is correct. So this here is great solution and answer. And I'm going to correct his fundamental theorem of algebra. However, having n having nth degree polynomial does not mean that you have n roots. It means that you can have up to n roots from 0 to basically from 0 to n roots. So or also imaginary roots, right? Also imaginary roots, or I can say complex roots, which we do not account for. Okay, sweet. So solution here is correct. That was question 8, which is great. So now I think I can fit in maybe 3 more answers, 3 more questions here. About 20 minutes left. So this is question 9. So hopefully I can do this. It says write the expression which is equivalent to fg evaluated to 5, right? So which expression is equivalent to fg and then 5. So now it's saying, and then I have 4 options, right? I have, this is f to the power 5 times g, sorry, not f at 5 times g at 5. B here is f of g at 5. C here is 5f to 5 times f at 5. And D here is 5 times g at 5. So this here is, you can think about the solution is this 5 here is kind of being distributed, right? You can think of the solution as this. You can think of it as that my function of f, so again, f of x, so it's going f at 5 first. So I have to figure out it's f at 5 first, and then it's g at 5 times g at 5, right? It's not simply, this 5 doesn't go, it has to be evaluated to both functions here. So in this case, A here is correct. B here is false, right? B here is a composite function. It's f of g at 5, right? So you're saying you're taking the g at 5 first, but then I'm evaluating f at whatever g of 5 is, right? It's not f at 5. The g at 5 does not necessarily have to equal. G at 5 does not necessarily have to equal 5, right? We don't know if this expression here is true. So in this case, B here is false in this case, and C and D here are obviously false, right? Again, it doesn't even account for this. C here doesn't even account for my g function, right? There's no g of x here, and there's no f of x here. They don't. The C and D doesn't even account for this function, for the other function here. So these two are definitely wrong, and A here is my correct answer. Again, this 5 needs to be distributed amongst. It has to be evaluated from f at 5 and times f at g at 5. Sorry, not f at 5. So f at 5 times g at 5, and not simply just one of those functions here. So again, this is you could think of this as a product. This here is a composite function. And these 5s here are simply just like vertical. You can think of this as vertical stretches, right? These are both vertical stretches here. So it doesn't actually make sense to do C or D here, because it doesn't even account for the other function. These are vertical stretches. So again, A here is our correct answer. So let's look at their answer here. Option A is true. That's great. We are given with expression fg at 5, and we need to find equivalent for it. So denote the pointwise multiplication of the value of the function at f and the value of the function point g at a, right? So this here is good. So this is what I mean by when we talk about distributive property. It's not really like distributive property, but it entails the same thing, where I need to take this value here of the function at 5 times the g at 5 as well. So here A here is correct, B is false, right? This is a composite function, right? That's what I wrote here. The composition of function, this is f at g of x. C is false because 5 times the f at 5 is not f at 5 times g at 5, and D is also false because, again, it's the same thing, except they wrote the g here. So in this case, a great solution and analysis for this problem here. So the solution here is correct. All right, so let's look at number 10. And I think we can do 2 more problems today, which is great, because I had the repeat. So I'm pretty sure I can do two more here. So it says, which of the following describes the roots of the polynomial function of that? So I have f of x equals x minus 3 to the power of 4 times x minus 6 to the power of 2. So I have these two things, and it's saying I have these functions here. These are all, or sorry, I have these statements here, and they're all talking about multiplicities, right? So it says here a -3 with, I'm going to say m equals 2, and 6 where m equals 4. B here is -3 is m equals 4. 6 here is m equals 2. This is all m equals multiplicity simply. 3 is m equals 2. -6 is m equals 4. And D here is 3, m equals 4. And 6 is m equals 2. Okay, so I have to figure out, okay, what is multiplicity? And what am I doing with those things here? So it's saying multiplicity is we're talking about the degree of what we have, like for example, we have a high order polynomial. We have something that's to the power of, in this case, 4 times 2 here. We can simply, what we can do is we can break this function into two parts, right? We can say there's this function here and this function here, right? Sorry, you can't see that. It's this function here, right? So I have x minus 3 to the power of 4. This is simply a quartic function. And what it does is, in quartic function, I have the x-intercept for this quartic function has to be, if I set this to 0, it has to be positive 3, right? Positive 3 is indeed a root in this thing here. And the multiplicity has to be 4, right? And again, it's a quartic function with the x-intercept of 3, which means this here is my correct answer. This here automatically makes this my correct answer, right? D is my correct answer here. As it's my x-intercept is 3, has a multiplicity of 4, which means it's the exponent here is 4, which means so that's the multiplicity. And if I separate this into x minus 6 squared, if I set this to 0, my x-intercept is obviously positive 6, and the multiplicity here is 2, right? It's squared, right? So again, you can think of these as separating them two functions, but when we combine them together, you get a function that's kind of that's a lot weirder, right? You have 4 times 2. This here would equal, if I'm I am multiplying exponents, so this here is my polynomial is in order of 8, right? And in the order of 8, in the higher order of whatever, an 8th polynomial here, my roots of those ones is I have a quartic looking multiplicity at 3, and I have a quadratic multiplicity at 6 here. So in this case, D here is my correct answer. And let me just check their answer here. So so D is correct, that's good. We're given this polynomial. Since we know the roots are the x-intercepts of the functions, we can set this to 0. That's good. And then they said this, right? So like I said before, x minus 3 to the power 4 equals 0. So x equals 3. That's awesome. And the x minus 6 squared equals 0, with 2 here is 3 as well. And so the root here is 6, and the multiplicity is 2. So that's good. So this here is a great solution. And analysis. I wish they kind of connected. They connected the question to the higher order polynomial that is presented in the question, and this would have been a 8th order polynomial. 8th order polynomial having x equals 3 and 6 as a root, as roots, where x equals 3 would have multiplicity of 4, and x equals 6 having multiplicity of 2. I think I misspelled multiplicity. Yeah, multiplicity. There we go. Great solution to answer. This solution here is correct. Awesome. And finally, my last question of the day, question 11 here, is stating what statement is true about the end behavior of the graph function. So we're talking about end behavior of function. Ooh, this is a really nice writing. I'm actually really happy. I don't know why. Whenever I write something nice, I'm really happy. So it's kind of weird. So I have this function. I have 1, 2. This should be a quartic function because it's going from quadrant 2 to quadrant 1. So I know it's some type of quartic function from advanced functions because I have 1, 2, and 3 of 3 turning points, right? This here turns out 1, turns out 2, and turns out 3, right? So, but we're talking about end behaviors here. So let's look at this. So A here says that f of x goes to, so I'm going to write them in the reverse order. So as x approaches negative infinity, as x values goes to negative infinity, f of x goes to positive infinity. So f of x goes to positive infinity. B here is as x goes to negative infinity, f of x goes to negative infinity. So as f of x, as x goes to negative infinity, f of x goes to negative infinity. C here is f of x is a decreasing function, is decreasing, and f of x and as x approaches positive infinity, f of x approaches negative infinity. And D states that as x goes to positive infinity, function value f of x equals 8. So this here is my function. And if you look at my function here, so it's saying, let's look at this. Let's look at the first case here. As x approaches negative infinity, f of x approaches positive infinity. This here is correct, right? As x approaches negative infinity, so as I'm going towards negative infinity this way, my function is approaching positive infinity. So this here is correct. B here, as x approaches negative infinity, f of x approaches negative infinity. That's incorrect, right? My function here is going up. My y is going up and not down. This here is wrong. C here is f of x is decreasing, and x as it approaches positive infinity here, f of x goes to negative infinity. As I approach positive infinity, f of x actually also goes to positive infinity. So this here is incorrect. And as x approaches positive infinity, f of x equals 8. As you can see, this is way above 8 already, which means this here is wrong. So in this case, A here is my correct answer. As x approaches negative infinity, f of x approaches positive infinity. So A here is my correct answer. Option A is true. That's good. From the graph, we can see the graph goes to positive infinity as x goes to positive infinity, and the values of f of x goes to positive infinity as the x values goes to negative infinity. So they verify what we did here. Function is neither an increasing nor decreasing functions. Over the interval 0 and 2 is decreasing, and over 2 to infinity, the function is increasing here. So again, I like how what they did here, and they separated in terms of decreasing functions. You have a decreasing function from here up to this point. This is increasing, and intervals of decrease would be this one here and this one here. Intervals of increasing would be this one here and this one here. I don't know what the specific points are, but I could basically show you here. And again, D is also false because my f of x here is much greater than 8, right? It doesn't simply just stop here when as x approaches infinity here. So this here, option A is true. So great logic, great solution. And this here is a perfect solution. Great solution and analysis here. So that's kind of my video for today. We went over to, basically 10 questions. I remember my first one was, there was one that was repetitive, and that's okay. Again, stay tuned for my videos. Again, I stream Monday, Wednesday, and Friday in terms of math, and Tuesday and Thursday for chemistry. And hopefully my videos are kind of separated into kind of grade 9 and 10 math for the first hour and grade 11 and 12 math for the second hour. So that's kind of how I'm breaking down kind of my videos now. If you're tuned in for the first time, or if you're constantly tuning in, thank you so much for supporting OneClass and supporting me as an educator as well. And as always, stay healthy, stay safe, and have a great day.